Okay, 2 more questions from the notes, then textbook, then pass your paper for practice. Now let's start with exercise 14. Complete class, complete the following table. So exercise 14, let me show you the answers. Okay, so here we have the table of values. Okay, then subsequently they want us to plot the graph. So I want you to place all these numbers on the left-hand side of the axis. It should not be on the right side, it should be on the left-hand side. So the scale, you'll be given 1 mark for the scale, 1 mark for the plots, and 1 mark for joining them up. Now, exercise 14 also required you to find out some information. Find the point at which the graph cuts the x-axis. So you have to identify where the x-axis is and find the point. So this graph intersects the x-axis here. This is our point of intersection. So find the coordinates. Here. Here. So 0.5, 0. It is at block 0.5, level 0. As seen. Here, this is this coordinate. X coordinate is 0.5, so that is half. It is found at level 0, corresponding to this. So part C. Part D requires your y-intercept. So look for your y-axis and find the intercept. So this is our y-intercept. It is at block 0, level 1. But because they asked for y-intercept, they didn't ask for coordinates. You only state the value 1. Next is to find the x value when y is given to be -2. So y being -2 refers to level -2. Level -2. So go ahead and find out where the guy stays. So level -2, drawing a line across, and we see that it intersects here. So this has a value of 1.5. So corresponding x value is 1.5. Now the last one, finding the area. Now frequently you will see this type of question where we have to draw lines. You draw the line yourself. X equals to -2. As you're writing notes, write down that this refers to block -2. So we visualize, we help ourselves visualize that we're looking for a vertical line -2, as well as a level -1. So we're going to be drawing a vertical line -2 and a horizontal line for -1. So find the area bounded by these 3 lines. We had our line, diagonal line was drawn, plus another 2 lines. So block -2 over here, x -2. A line, y equals to -1 horizontally, y equals to -1, and the area bounded by these 3 graphs. Over here, this is a triangle. So area of a triangle of half times base times height. We know that. So area, half times base times your perpendicular height. But do you know that there's a trap over here? The base from block -2 all the way down to block 1, depending on how you count or depending on how you interpret it. Some students will see as from -2 to 1, oh, that's 3 units. But some people have a weird misconception that 1 cm is 1 unit. Some. So they see 1 cm representing 1 unit. They think that, oh, 1 square, 2, 3, 4, 5, and 6. So they think that the base is 6. But is the base really 6? Is the base really 6 units? No, the base is 3 units from -2 to 1. That is a total of 3 units only. Okay, so we can substitute the base, half times 3. And they are happy. Oh, yeah, okay, I didn't fall for the trap. So they go ahead and do the same for the vertical axis, the vertical line. So they go this way, from here to here. They start counting. But do you realize that the scale is different? In the horizontally, 2 cm represents 1 unit, but vertically, 1 cm represents 1 unit. The scale is different. So in this case, we have from 5 to -1. This is actually a total of 6 units. Can you see that? Vertically, although it looks shorter, it is representing 6 units. Horizontally, it looks very long, but it's actually representing 3 units. The scale matters. You cannot simply just count squares and decide the length and the height. So in this case, we have half times the base representing 3 units and the height 6 units to give us a total of 9 square units. 9 square units. I did not write square centimeters because this is not in centimeters. The horizontal distance and the vertical distance, they are represented by units, which we don't know what are the units. We just call it units. In this case, we call them 9 square units. Okay, so half times 3 times 6. Take note of the scale. Please don't fall for the trap. And the final notes question. So exercise 15, we will see that it's very common. Usually we'll leave this blank, you fill in the blanks. So find the 2 values, draw with the scale, draw more lines, find the area. Okay, so the values, 1.5, 2.5. So state your values for P and Q. Drawing the graph, we are expecting a diagonal line sloping up. Sloping up, why? Because the coefficient of x is positive. The y-intercept is +2. Over here. +2. So they wanted us to draw more lines. What were they? X is -1. So if you are writing notes, this will be our block -1. This will be level 4. Oh, last year when I taught this to the last year Sec 1, right? I think some of them thought it was very childish. Why is Mr. Wong talking about block and level? So lame. They don't want to learn. They think they can do it. Right? You hear me say that over and over again? Doesn't sound like mathematics. But I feel that it's a way to help some students remember. But if you think that it's very lame and you have a better way of doing it, please go ahead. But don't fall into don't get yourself in a position where you listen to me say it over and over again and you think you know how to do it. When the day comes during your exam, you start wondering, is x equals to -1 a vertical line or a horizontal line? If you find yourself in that position, then you can't blame anybody because you decided to learn it your own way, to remember your own way. Okay, so options are given to you, recommendations are given to you. It is up to you to decide how you want to remember. So block -1, level 4. So draw your block -1, this vertical line. Label it. Otherwise, we do not know whether we should give you the mark or not. Level 4, horizontal line. So find the area bounded by these 3 lines. Again, triangle. Area, half times base times height. Base from one side. Okay, let me see. This is 4. From -1 to 4, we have 5 units. So 5 is the base and the perpendicular height over here, 1.5 to 4. Total will be 5/2, 2.5 units, 5/2. So you get 25/4 square units. Okay, so 6.25 square units. You can leave it as an improper fraction, no problem. So simple? Simple? Do you think they will give you a triangle next in your end of year exams? What other shapes have you learned? Okay, we won't ask you to draw a circle. For, yeah, probably parallelogram. I did not see the questions. I did not set the paper. But if I was setting, I would want to combine different topics. Perhaps I'll make you draw a parallelogram. Perhaps I'll make you draw a rhombus. Perhaps I'll make you draw a trapezium and find the area. And now we move on to our textbook questions. 11.4, question 4 and 9. Okay, now, copy and complete a table for this equation. Shouldn't be a problem, just substitution only. Now, part B, I want you to pay attention to the word state. Did it say calculate? Did it say calculate the gradient? No, they didn't say calculate. So are you expected to use the gradient formula? Y2 minus y1 over x2 minus x1. No, not expected. Are you expected to use rise over run? No, you're not expected. You're expected to just look and say what the gradient is. Are you going to do that? So y equals to negative 2x plus 3. Y equals to mx plus c. Gradient is? What's the gradient? Negative 2. Just see only and state. State your age. You don't need to think, just state. Okay, no calculation involved. So gradient negative 2, y-intercept is 3. Next is to draw the graph following the scale. So this is what we expect to see. Okay, sloping down. Make sure you have your axis labeled x, y. Make sure you have your plots drawn. Make sure you have the label. Next one, question 9. Then only 2 questions. Now, the cost y of printing x t-shirts is given by this function. Y equals to 8x plus 150. What does x represent again? T-shirts. So if I want to print t-shirts for this class, I need to find a supplier, right? Then the supplier needs to tell me, how many color do you want? The more color, the more expensive it's going to be. How many t-shirts are there to be printed? So the more t-shirts that we have to print, the larger the final cost, isn't it? However, but the more the number of t-shirts, the lower the cost is going to be for one person. Do you know that? Does it make sense to you? Now, it is shown in this equation also. The total cost is given by 8x plus 150. So what happens when I want to print 100 t-shirts? So the x value is 100. We're going to substitute the 100. That is our input into the function to find the total cost. So let's do that first. Substituting, we get 950. Okay, so the total cost will be $950, but the cost per t-shirt, one t-shirt, would then be 950 divided by 100. So each person pays $9.50. One person, $5.50. Part B. What does the constant term 150 represent? The constant term is the term that does not have x. What does it represent? That 150. Hey, look at it. If you print 0 t-shirts, how much do you have to pay? Oh, really? Do you really pay 0 when you print 0 t-shirts? Look at the equation. When x is equal to 0, what is the value for y? 150. When you print 0 t-shirt, based on the contract, you have to pay $150. Even if you print 0, no. Or if you print 1 t-shirt, how much do you have to pay? 8 times 1, which is 8, plus 150. So $158. 1 t-shirt, $158. What kind of t-shirt is that? You know what to do. Okay, I don't know that one. So anyway, back to this. Based on the contract, there is a fixed price of $150, regardless of the number of t-shirts you have to buy, that you have to print. That is why we say the more t-shirts that are printed, the lower the cost is going to be for one single t-shirt. Why? Because we are going to be dividing that 150, that fixed cost, among all the people who are buying the t-shirt. If I have one person who buys the t-shirt only, that $150 will be borne by that guy. If I have two people buying t-shirt, that $150 will be borne by those two people. A real life example. This may not be very obvious to you, but when you order Grab, we order Grab food, okay? You know, different people buy different items, right? You should pay for your own item, but there's a fixed charge. Hey, there is a fixed charge called the delivery fee or the platform fee. This platform fee, delivery fee, is going to be divided by all the people who bought items in that same delivery. The more people who share, the lower it will be per person for the fixed charge. But if it is only one person who buys the food, that one person pays for that fixed charge. That is the significance of this 150. So in this particular situation, next time when you go to Poly, JC, you make your class t-shirt. I say next time because in Evergreen, we don't have class t-shirt. Why? Because we don't want you all to have it. Just a PE t-shirt. So anyway, when you go and make t-shirt next time, you will have to pay a fixed charge. Why is there a fixed charge? Oh, that is very childish for you to think that. It is not because they want to scam you. It is because they have to make a mold, M-O-U-L-D. The design that you are submitting to them, they have to use a machine to either carve out physically a mold to carve out the design so that they can use it to like stamp on the clothes. So that mold over there, $150. You just have to carve it one time, right? They just stamp on as many clothes as you like. So that is the fixed charge. That is one example of how this fixed charge could be understood in this context. So what does it represent? In our explanation, we say it's just the fixed cost of printing the t-shirt, regardless of how many t-shirts you are printing. And finally, what does the 8 represent? Yes. Sorry? The proper term to use is fixed cost. So what does 8 represent? It represents the extra cost per printing of the t-shirt. Now, if we have one person printing the shirt, he pays $158. If we have two people, they pay $166. The more people we have, when we reach 100 people, they pay $9.50. If we have 1,000 t-shirts being printed, we have $150 that fixed charge divided by 1,000 people, which then becomes very small. And that is added on to the $8 per t-shirt. If I have 1 million people buying t-shirt, the price per t-shirt gets very, very close to 8, which is the supposed cost of a t-shirt only per person. Okay, it is just a matter of dividing the 150 by the number of t-shirts that are printed. Now, do you know why we want to do bulk purchase? Your Evergreen 2021 t-shirt. Bulk purchase, one design, save on the cost. If you have many designs, we need many molds, and the cost will be more expensive. So this is our 2 questions from exercise 11.4. We got one last one from your revision 3. Okay, question 12. So similar question yesterday, I talked about the duster, the fixed point, and my position relative to it, where I started from. Today, this question is on Jenny, 3 meters away from a lamppost. So let it be the lamppost again. And this time I'll be Jenny, I'll be 3 meters away from the lamppost. And I begin to run at a constant speed away from the lamppost, so away from it. In a particular direction, away from it. After t seconds, the distance is given by y equals to 2t plus 3. Does the 3 sound familiar? That 3, y equals to 2t plus 3. The question, they say that Jenny was 3 meters away. Is it a coincidence that these two are 3's? No. At the start, what is the time at the start? What is the time at the start? One more time, louder. What's the time at the start? 0. If we don't say that, some of you still dreaming, huh? Some of you were saying at the start, time equals to 1. Honestly, how many of you are thinking time at the start is 1? We will see during the exams. At the start, time equals to 1. That is wrong. At the start, time equals to 0. Okay? So when we substitute time equals to 0, 2 times 0 is 0, plus 3 is 3. So at the start, I am 3 meters away. They did not have to say that first sentence. They could have just given you an equation and asked you, where was Jenny at the start? So your answer has to be 3 meters away. Okay, then we have the graph. As expected, we start off at vertical axis 3 meters away. And we see that as time passes, she gets further and further away from the lamppost. Okay, so here, this is the time axis. This origin, distance from the lamppost, from the vertical axis. At time equals 0, 3 meters away. At time equals to 2 seconds, the person Jenny is 7 meters away. You see that in 2 seconds, the distance has increased from 3 to 7. That's an increase of how many meters? 3 to 7, how many meters? 4 meters in how much time? 2 seconds. Let's move on. 4 seconds. At time equals to 4 seconds, what is the distance? 11. Right? So 11 after 4 seconds. That's an increase of how much? From 3 to 11. 3 to 11, increase of how much? 8. In 4 seconds, there's an increase of 8 meters. What do you think they are trying to get you through? Okay, so we look at that for the questions. After how many seconds was Jenny 15 meters away from the lamppost? Do you understand this question? After how many seconds was she 15 meters away from the lamppost? How are we supposed to do that? I don't know. Go back to the graph. 15 meters away. Should we be looking at the vertical axis or the horizontal axis? Vertical or horizontal? Which one tells us about distance? Vertical, right? It already says that. The units is in meters. We look at the vertical axis, we find 15. Okay, so draw a line 15 and come down. It says 6. 6 what? 6 seconds. What do you think is the significance? What does it mean? What has 15 meters got to do with 6 seconds? Based on the graph, it means after 6 seconds, she is 15 meters away from the lamppost. So that is our first answer. Okay, so much written. You don't have to write that. The answer is straight away 6 seconds. Don't need to write anything else. Just 6 seconds can already. Part B. Find the gradient of the graph. Now, they said find. They didn't say state. They just want you to find it. You can do it any way you like. So, anybody wants to do calculation? y2 minus y1 over x2 minus x1? Anybody wants to do rise over run? Or do you just want to look at it and say gradient equals to 2? Yeah, very obvious, right? Coefficient is 2. 2 lah. Don't need to do so much work. So straight away answer. Part C. What is the physical interpretation of the gradient of the graph? What does it mean? Okay, now I'll do this on the board using the gradient formula. Gradient. We call it two different ways. First, rise over run. The other one is gradient equals to y2 minus y1 over x2 minus x1. I want you to pay attention to the units used. in the rise. What is the unit for the vertical axis? What are units for the rise? Meters. So this is a meters. What is the unit for run? Seconds. What does this horizontal line represent? Divide, right? Divide. It is divide. So our final answer, whatever this number is going to be, has units. What are units? Meter per second. If you do it this way, y2 minus y1 over x2 minus x1, y being the vertical values. What is the unit for y2? Any number on the vertical axis. What is the unit in this particular case? Meters. This is meters. Meter minus another meter is the distance minus another distance. You get the numerator in meters. Denominator, seconds minus seconds. You get it in seconds. Same division. Equals to answer meters per second. So what do you think the gradient represents? What does this remind you of? Meters per second? Speed. What does it represent? It represents the speed. The speed at which she runs. So what is another way of saying it if you don't want to use this? So what I told you yesterday, it represents the rate of change. Or then you go back to the vertical axis. Rate of change of what? Vertical axis, distance. Rate of change of distance. What is the horizontal axis unit? Seconds. Okay, so I'm showing you different ways to get the same answer. It is the same interpretation. How does the distance change with respect to time? This particular example describes speed. For this particular example, other examples, it could be velocity, it could be acceleration, it could be cost per t-shirt, it could be cost of selling a piece of graph paper, for example. So there are many different variations. So this brings